Hello everyone, welcome to our channel Simplified Computer Science Concepts of Professor Rutuja. Today we will be learning about one of the important page replacement algorithm, that is optimal page replacement algorithm. So let us begin. So this optimal page replacement algorithm, the main funda behind is that it will replace the pages which will not be used for longest period of time. So here just focus on the word will not, which means will means in future. So whenever we are referring the reference string, we have to compare the number of the frames in the forward direction. So why I am saying that I will be showing you in the next slide. Also it is important, why? Because it produces lowest page faults as compared to first in first out, that is FIFO algorithm, and LRU, that is least recently used algorithm. However, its implementation is difficult. Now let us understand this with the help of an example. So this particular question is given in front of you, that means calculate the number of page faults for the following reference string. So we have to calculate the page faults. Assumption is that the number of frames are 3. This is the reference string which is written in red, which means that CPU wants to access this particular pages of a particular process. That means we have to bring these pages into the frames of the main memory. So we have to write this string in such a manner and now arrange it into the frames. So how many number of frames? 3 frames. So initially they are empty. Now we have to bring this page number 7 in the frame. So when we have to bring it in the main memory, that means it is a page fault. So now we have brought that. Now the second page that we require is 0. Is it there? It is not there. So again we have to bring that 0 into the frame. So again that is a page fault. Then comes 1. 1, check 1 is there into the frame or not. No, it is not there. And we have to bring it. So now we will bring it and again it is a page fault. Now comes 2. When 2 comes, we have to check all the 3 frames are occupied. They are not empty. So now we have a challenge. So out of these frames, which frame is to be emptied so that 2 can occupy itself into number of frames. So how do we do that? So we have to check this string, reference string, in a forward direction and find such a page out of this already present pages into the frames. Which particular page will not be used for the longest period of time. So now when 2 comes, we will check 7. So here 7, if you check, 7 is nowhere in the string ahead. Then comes 0 and then comes 1, which means that if 7 is not there in the string, straight away we can replace 2 with 7. And when we are replacing, that means there is a page fault. Now comes 0. So just check, 0 is already there into the frames. So no need of bringing it. So in the frames, that means it is a hit. Right? Then comes 3. Again, check the contents. 3 is there, 3 is not there. Then how we have to check? We have to check the string in the further direction. So for what we have to check? Out of 201, which particular page is used for, will not be used for the longest period of time. So 0 comes immediately after 3. So 0 is not the 0 cannot be replaced. So 2 comes again and the last one that comes is 1. So which one comes at the last? 1 comes at the last. That means 1 will be replaced by 3. And that is a page fault. Again come to 0. So 0, check with the contents. 0 is present. That means there is no need of bringing it into the main memory. It is already present. That means it is a page hit. Then moving ahead to 4. Look at the contents of the frames, that is 203. Now check out of this 203 which one is coming at the last. So 2 is coming immediately after 4, then comes 3, and at the last comes 0. So 0 is the one which we will replace 4 with. So it is now what? 243, which means it is a page fault. Then comes 2. Check the contents. 2 is present, that means it is a page hit. No need of bringing it from the hard disk. Then comes 3. 3. Check for 3. 3 is already present. So again there is no need of bringing from hard disk to main memory. It is already present. So it is a page hit. Then comes 0. So 0, again we have to compare the contents of the frames. It is 2, 4, 3. So 3 is immediately after 0. Then comes 2. So which one is not there in the reference string? 4. So we can definitely replace this 4 by 0. So now the string will be 203. So it is again a page fault. Then comes 3. Now for 3, check the contents of the frames. It is there, that means that is a page hit. Then comes 1. Now here again check the contents, 203. 1 is not there, so we have to check in forward direction. Which one is coming? 2 is coming, 0 is coming. Which one is not coming? 3 is not coming. So simply 1 will be replaced by 3 will be replaced by 1. So now the string becomes 201 and it is a page fault. Then comes 2. 2 is already there in the frames, so no need of bringing it. So it is a page hit. And the last one is 0, which is again already present into the frames. So it is also a page hit. So just observe this. How many hits are there? So 1, 2, 3, 4, 5, 6 and 7. So 7 hits. And number of page faults is 1, 2, 3, 4, 5, 6, 7 and 8. So I hope you have understood this concept. Thank you for watching this video. Please do like and share, subscribe to the channel. Thank you everyone.